Uh, okay. Okay, we'll start the lesson. Today we want to talk about an important topic of root equations. Hello, the lesson has started. Okay, so now what is a root equation? Again, when you see the word equation, you understand what is the meaning. You have equality in which you have an unknown, you are supposed to find it. Yes? That is an equation. But now you call it root equation. It means that you have a third sign in the equation in a way that the unknown is under the third sign. So for example, x minus square root of 2 equals to 0. It is an equation. When we say that I have a root equation, it means that you have an equation. Equation means that you have an equality and an unknown. And here when you say root equation, it means that you have this radical sign, which the name for it is the third sign, yes? So this is a third sign, this is a third sign, I don't know, this is a third sign. These are the second root, the third root, the fourth root, we call them third sign. But this is not a root equation because even though you have a third sign, but below the third sign, you don't have any unknown there. So this is just a normal equation. If I ask you what the answer is, you just tell me x is equal to square root of 2. But now, if I put the third sign on x, and I ask you the same question, this is a root equation. Because first of all, it is still an equation. You have equality and you have unknown, but this time your unknown is below a third sign. If this happens, then you say that this is a root equation. And the general strategy, this is important to understand because these problems can be different. So the general strategy to tackle root equations is to get rid of the third signs, all of them. Okay? In this case, it is extremely simple. If I want to get rid of a square root sign, what is the enemy of a square root sign? What is the one that kills the square root sign? Yes? Power. Here, which power? Power 2. So this is the general strategy, but it is not always that simple. Of course, this is an E-level question in the book. So if you want to solve it, you try to isolate your unknown, again as before. But to isolate x, you have to get rid of this third sign. So then you raise both sides to power 2. And then this power of 2 will helps us to get rid of the third sign. You get x. On the right-hand side, 2 to power 2 is 4. Again, if I ask you what is the meaning of this number 4 you found, you will tell me this is the only number that if I replace x with that number, the left-hand side matches with the right-hand side. And then I would say x equals to 4 is a solution. Okay, so I don't know, might be you can have this equation. You can have square root of, let me choose it from your book, x plus 12 is minus 7 equals to 0. So how can I solve this one? Again, the goal is to isolate x as usual. So I try to isolate x as much as I can. I move 7 to the other side. But then I want to get rid of the third sign because my goal is to isolate this. You can imagine that x is held captive by this prison. If you want to, you have to remove the walls of the prison by raising it to power 2. So then it becomes x plus 12. The right-hand side becomes what? 49. And then you want to still continue isolation. You move 12 to the other side, it becomes 37. Okay. But there is something that I immediately want you to understand. There is a subtlety here. For example, if I give you a square root of x plus 12 plus 7 equals to 0, let us see what happens. So, square root of x plus 12 plus 7 equals to 0. Apparently, you want to follow the same strategy because it is still natural to do that. So I move 7 to the other side. It becomes minus 7. I raise both sides to power 2. Let us this time do it in 2 steps so that you can feel I'm not cheating. And then this power of 2 will help me to get rid of this, so it becomes x plus 12. But what happens to minus 7 to power 2? It becomes 49 again. And then when I move this to the other side, it becomes 37 again. And then you say that, okay, I am happy I got my answer, but the bad news is that this is wrong. Why this is wrong? Let us first show that this is really wrong. This was not wrong because you can check your solution is true. How? By going back in the scratch work, go to a scratch paper, replace x with 37. It becomes the square root of 37 plus 12 minus 7, and then continue this. This one plus that one is a square root of 49 minus 7. But what is the square root of 49? Is 7 minus 7. It becomes 0. So that is correct. When I check this back into my equation, I really find that this answer I got is true, is correct. But if I want to do the same thing here, what happens? I go back here in the scratch work. So I remove x and put my answer instead. So it becomes 37 plus 12 and then plus 7. And then I continue. This one plus that one is 49 as usual, as before. And then I have 7. But this time, see what happens? This becomes 7 plus 7. The answer is 14, but the 14 is not equal to 0. At least you immediately realize this answer is not correct. It is wrong because even though it seems that I am doing everything legal from mathematical point of view, but that is strange. I get an answer which is not correct. It is not working, you know. But I did the same thing. I got the answer which was working. So in this case, the answer was true. In that case, the answer is false. First of all, this is a bad news or good news, I don't know, but you have to be aware of it. In root equations, with even, not the third, with even roots, this can happen that you can have what is called a false root. So this is a false root. So you derive it, but this is not reliable. So that's what I'm saying. In the previous problems, we solve the problems if we do not miscalculate or miscompute, the answer that we get is always true. But in root equations, even if we don't miscompute anything, which I didn't miscompute anything here, anything, the answer that you might get is not probably the answer to this equation. So you have to always check the answers that you get are true or false. In this case, this is a false root. And if I ask you, so what is the root of this equation? The answer is that this equation does not have any roots. There is no number that you can find to put here so that it works. Okay, so that's the answer. The second thing is that, Bobak, you told me that I need to find a systematic way to solve if I am supposed to check if the number is correct or not. So why shouldn't I check from the beginning? The answer is simple, because if you don't know 37, how many potential numbers are there to check? Infinitely many. You can check every number to see if it works or not. But this process narrows it down to just one single number. So you don't have to check all possibilities. You only check one number that is a potential answer, and that turns out to be false, so you are relieved. There are no solutions. But for example, if I choose 1 and I put 1 there, I see it doesn't work. I put 5 there, it doesn't work. I put 1/2, it doesn't work. Then okay, it is not clear yet. Might be there is another number that it will work. But this shows no. If there is a number that is supposed to be working, it should be 37. And if you check it, it doesn't work. So it means the end of the story. There are no solutions. Yes?
What if x is minus 19?
No, so check any number that you want, but I hope that I could convince you, if there is a root for this equation, according to this calculation, that root should be 37. It doesn't tell you 37 is the root. It tells you that if there is supposed to be a root, that root is 37, and we check manually, 37 does not work, so it means there are no roots. Okay, so that is the logic behind that. Yes?
Yes, but is there a solution for this?
No, that's what I'm saying.
Minus 19 plus
So minus 19 here. So if you put minus 19 plus 12, it becomes minus 7. Square root of minus 7 is nonsense.
Can't we square it?
No, don't get confused, you know. If so, your claim is, might be you are imagining that minus 90 is an answer. What does this mean? It means that if you go to your equation, replace x with what you propose. Oh, sorry. Then this means that this is 0. If you say minus 19 is a root, it means that when I replace x with minus 90, the left-hand side, after being calculated, it becomes 0. But that is not true. Why? Because if I add this to this one, it becomes a square root of minus 7 plus 7. Yes? A square root of minus 7 is not a number at all. Yes? So I cannot say that I have a number. I add it to something which is not a number, and the answer becomes the number 0. That is not correct, yes?
When you checked it's square root of 49 plus 7, then below you determine that square root of 49 is 7, but can't you say that square root of 49 is minus 7?
No. How many times I told you? The square root of a number, if I say x squared is 49, if I ask you what x is, then x have two answers, plus and minus 7. So it means that x is equal to a square root of 49 plus or minus, and then you calculate it becomes plus or minus 7. But if you take your calculator, punch this in the calculator even hundreds of times, you will never ever get even one single minus 7. The square root of 49 is one number, and that is 7. You might say, why? Because I told you it's a convention. Mathematicians have chosen to use this symbol for the positive one. If I ask you how many numbers are there whose second power is 49, of course there are two. One of them is 7, one of them is minus 7. But the square root of 49 doesn't tell you how many numbers are there whose square is 49. It is asking you which positive number is there whose second power is 49. That's different. So when I write square root of 49, take your calculator and check it. Even you start punching 49, square root of 49 there. Every time you punch it and execute it, you will get 7 for sure. So square root of 49 is not the same question as x squared equal to 49. X squared equal to 49 is asking you to find all numbers whose second power is 49. In this case, of course, you answer minus and plus 7. Square root of 49 asking you which positive number is there whose second power is 49. And that is only 7. And you might ask why. There is no why. This is the symbol mathematicians use for the positive one. If you want to say what about the negative one, they have to show it in this symbol. The minus the square root of 49 is minus 7. Square root of 49 is only 7, not plus or minus 7. Is that right? Okay. So if I want to review it fast, the general strategy to tackle a root equation is raising to powers. Yes? But the second thing that you have to be careful is that when you do this, even if you don't miscompute anything, still there is a chance that what you get is not working. And that is what we call a false root. A false root is a root that you get under legal circumstances. You are not doing a miscalculation, but still the answer does not work. If that doesn't work, it's a false root. So if I give you this question in the exam, this is part of the solution, and this is also part of the solution. No longer it's a scratch work. So this has to be in the solution as well, and then you say that therefore 37 is a false root and there are no solutions. So the whole package I presented here will be the solution to this problem. But here in this problem, you find it. This is also included, not in a scratch word. You have to put it in the solution, and then you say, no, this is this time a real root. It's not a false root. Yes?
So let's say we forget that other thing that's...
Okay, if there are 2 points, you will lose 1 point.
Okay.
Yes. Is that clear? Okay, there is another very important thing, is that the way that you organize this root equation to raise it to power 2 is extremely important. Because some of you, this is still a common mistake, hopefully you can be aware of not making that mistake. For example, if I want to solve this equation, some people say that let us raise it to power 2 just right away. Okay, it is according to the strategy, but it is not working. I want you to see why. Because some people say that, okay, let me write it here. They say that, okay, I raise it to power 2. This is not wrong. That's completely acceptable. 0 to power 2 is 0. And the people sometimes write it like this. This is very, so they write it like this, because they say this one to power 2, this one to power 2, and then they get x plus 61 equals to 0, x is equal to minus 61. We know that this is wrong, because we got the answer, the correct answer is 37. But which part of it is wrong? Do you see which part is wrong? Which part is wrong? Why this is wrong? You had the quiz about this topic. The first quiz, not the second one.
Minus 7 to the power.
No, that one is for positive 49, yes? So can you tell me, if I give you this in the first quiz, I should have given you. So if I give you this in the first quiz, let me make it simple. What's the answer to this? You see, you shouldn't fall into the same trap. If you write the first one squared plus 7 squared, you are using this idea. Still, you see, you have this in mind somewhere. This is not correct. What is the correct version? There is a 2xy as well. So if I say, what is this? You will tell me there are 2 terms subtracted squared. The first one squared minus 2 times the first one times the second one. Yes? And then plus the second one squared. So the answer becomes x. It becomes 49. I agree. But there is something that you miss, and that is 14 square root of x. This is the correct way. So, another point that I want to make you understand is that this is the same problem, but moving and then squaring was working, but this method is not working, because first of all, this is not the correct way. If you want to do it in correct way, what do you do? So if you want to do it in correct way, you do this, and then you say the first one squared, 2 times the first one times the second one, and the second one squared equals to 0. So you see, your strategy fails. Because what was the reason we want to raise to power? Because we want to get rid of third sign. But in this way, even though I haven't done anything wrong, this is 100% correct, it's 100% correct, but 100% correct and 100% useless. This can happen. Why it is useless? Because still another third sign survives. Yes? So these are general pictures, because I can teach you case by case, but that is not good. I want you to have the grand picture so that you can be creative. So the goal is to get rid of the third sign, but legally and efficiently. Efficiently means that sometimes you have to understand that is it a good time to raise it to power? It was not a good time, because I can have a lot of more big troubles. You see, this problem is even harder than the starting problem. So I'm not making the problem simpler, I am making life more uncomfortable for me. Yes? Is that question? Is that understandable? So I want to give you a lot of examples. Little by little, I increase the level of difficulty so that we can solve these kinds of problems, okay? So far, I haven't given you any other search signs, but might be we will study a little bit of those as well. So this is the question now. Solve the following root equations, and I want to give you some examples. So remember, you need to organize them so that when you square them or raise them to power, the search sign is completely gone. The second thing, after you solve your problem, checking the answer is part of the solution. Yes? Okay. So let me write the equations. Let me choose some problems from the book first. So whatever you learned in solving equations will also work here. So don't forget about them. Okay. So square root of 1 minus 2x is equal to 3. So I will solve this one myself for you, and then I will give you other examples. So in the exam, I ask you to solve the following equation. How do you realize this is today's lesson? Because you see there is a search sign and you are looking for x. Whenever this happens, this is under the topic of root equations. So you remember today's lesson. The strategy is to get rid of square root sign. Is it a good idea if I raise to power 2 right away? In this problem, yes. So this is what you do, okay? I write it down. You don't have to write this part, but I want to write it so that in the future, when you see it, you recognize what I'm doing. So the first step is to raise both sides to power 2. The second step is that this has a simpler name. What is the name for this? This power of 2 helps me to get rid of this. So what is left? 1 minus 2x. What is on the right? 9. And this is a very standard Math 1C problem. So I move 1 to the other side. It becomes 8. Yes, 9. I move 1 to the other side. Minus 1. It becomes 8. And then what happens? X becomes what? Minus 4. But in this kind of questions, don't immediately accept it because it might be possible this is a false root. How should I check that? So you write here, left-hand side is equal to a square root of, you replace x with what you got. So it becomes 1 minus 2 times minus 4, and then calculate and see if it reaches to the right-hand side. If it did, then it is correct. If it didn't, then it is a false root. So what happens here? Minus 2 times minus 4 is positive 8, positive 1, positive 8, positive 9, and then 3, not plus or minus 3, only 3. And that is equal to the right-hand side. So is it a false root or not? No. So this is acceptable. Is that right? So this is the strategy. But of course, these problems could be really harder. Yes? Yes? Yes, yes. Okay, so let me give you a level 2 problem in the book. I can also solve this one myself. So this is the problem in the book. So I have x plus 10 equals to 7 square root of x. This is a better problem. No, they have considered this is still level 1 problem. We'll come back to it. Okay, so let us review everything. Let us assume that at the end of the year, you receive this question. How do you understand this is today's lesson? Because it is an equation, I ask you to solve the following equation. How do you know this is today's lesson? Because you see a search sign. Under the search sign, you have the unknown. Yes? That is today's lesson. And what is the general strategy to tackle the problem? To get rid of the search sign by raising to appropriate power. So in this case, which power is suitable? 2. So what I do, this is part of the solution. What I write in blue is important. I raise this left side to power 2, but the right side is this combination. I have to raise it to power 2. But now this is Math 2C lesson. X plus 10 to power 2 is not x to power 2 plus 100. Do you remember? So this becomes the first one squared. 2 times the first one times the second one, which is 20x. The second one squared is 100. Yes? And what happens to the right-hand side, can you tell me? Be careful. Here is addition. I have to use this long version. This is multiplication. If I have a multiplied by b to power 2, am I allowed to write a squared b squared dot? For multiplication, yes. So this becomes what? 7 to power 2, square root of x to power 2, which is x. So this is a normal equation, but normal quadratic equation. Yes? So I have to use ABC or PQ formula as you like. So, but I know that for using those formulas, I have to move everything to the left. I move this to the left. Can you do it in your head? So 49 goes to the left, becomes minus 49x. There is a positive 20x there. So what is left? Minus 29x. Yes or no? And then plus 100 is equal to 0. Okay, the number is a little big, so might be I give you access to the calculator, but you know that if I want to use ABC formula, that is exactly the topic of the quiz. By the way, I made a video for the quiz and solved the problems. The people who were absent, please check it out, and the people who made some mistakes, plus I think it's good to see the solutions. So A is equal to 1 in this problem, B is equal to minus 49, and C is equal to 100. So what should I do? I need to calculate D. D has a formula, B squared. I'm just using ABC formula. So this is minus 29 to the power of 2 minus 4 times 1 times 100. So what is 29 to power 2? Do you know? So let me check it. 29 times 29 is 841. So this is 841. This becomes 400. The sign is negative. And it becomes 441. Yes? And then you have the formula. Do you remember what the formula is? Minus b plus or minus what? Square root of d divided by 2 times a. So what is b? b itself is negative. There is a negative sign in the formula, so minus b becomes positive 29 plus or minus the square root of 441, and then you have 2 times a, which is 2. But the square root of 441, I have it in my memory, it is 21. So it becomes, you can use the calculator, of course, plus or minus 21 divided by 2. And then you have 2 options. 29, can you do it in your head? 29 plus 21, 50 divided by 2, 25. 29 minus 21, 8 divided by 2, 4. But be careful, don't accept them yet. It might be one of them or 2 of them, or I don't know. They are false roots. You have to check both of them. So it is lengthy. So not only you have to solve the equation, but you are not relieved there because it might be a false root. And because there are 2, unfortunately you have to check both of them. But it is better than nothing. Potentially, I have infinitely many choices. Using this method, I narrowed it down to 2 cases and I can check them. Yes? Let me do that and then I'll come back to you. Did I make a mistake?
No, it's just I have a quick question.
Yes?
Do I have to check in the original equation or can I check?
No. Exactly in the original equation. Because of course, this always works here. This part is not a false. I will explain that. That's a good question. Don't go back and check them here. It always works. Because if you don't see this, what do you see? You see a quadratic equation. In the quadratic equation, what you get is always true. The problem is that this equation is not exactly the same as equation as before. I will talk a little bit about that. Okay, so but before that, let me finish this problem. So what do you do? I would say it. I would write it in this way: x to be 225. I want to check this. How should I check that? I start from the left-hand side. So here I can calculate the left-hand side. If you want, you can do it always, the right-hand side. The left-hand side, instead of x, I put 25 plus 10. What is the answer? Very simple, 35. On the right-hand side, I have 7. I have a square root. Instead of x, I put 25. But what is the square root of 25? 5. So it becomes 7 times 5, and that is 35. And this is okay. So that is not a false root. It is a real root. So I accept it now. I put it in a box now. I will do the same thing for 4. Yes? So x equals to 4. But be careful. These are parts of the solution. They should be in your paper. So then the left-hand side is equal to what? 4 plus 10, which is 14. The right-hand side is what? 7 square root of 4, which is 7 times 2. This is also 14. So that's good. So both of these answers are actually acceptable. None of them is a false root. Okay? Is that understandable? So I will write one of them for you to solve them, and then we increase the level of difficulty a little bit, okay? Okay, so this is a level 2 problem in the book. And I want to wait for you. Of course, it seems a little bit harder, but I think if you have listened to me carefully, you can manage it on your own. So this is the question. X plus 1 minus 6 the square root of x plus 1, and then you have plus 5 equals to 0. I think, of course, this is a little bit big gap, but I think you can manage it. It's not hard. Let me wait for you a little bit. Should we solve it now? So this is a problem in your book. How did you solve it? Yes?
I moved 6 square root, 6 multiplied, I moved that to the other side.
That's a good idea. I hope that you agree with me that this is not a good idea to raise it to power 2 like this, because you will be in real trouble, yes? So I think your idea is good. You say that, okay, I move this square root to the right, so the price that you have to pay is to make it positive. And then you are left with x plus 1 plus 5. So no one writes plus 1 plus 5 because there is a better name, and that is plus 6. Then I raise it to power 2. It's a good point to do that. So you raise this one to power 2. The whole left side to power 2 is equal to the whole right side to power 2. So you have to be careful about your algebra. Which rule is that? This is a squaring rule. So the answer becomes the first one squared, 2 times the first one times the second one, and the second one squared. But what about this one? This is still on the board, you see here. That is that rule. AB squared is A squared B squared. So that's a product. So I can raise this one to power 2, which becomes 36, and raise this one to power 2, which becomes x plus 1. But that is the wrong way to do it. You have to put a pair of brackets. Agreed? Okay, and then this is the old lesson. So this is the exact lesson that we had the quiz on Friday. So that's a quadratic equation. You have to solve it. But this is also simpler, the simple form. Do you remember? That's a good thing that we have the opportunity to practice as well. So I would copy and paste the left side. I multiply 36 in. Okay, so what happens? I move this to the left. X squared is already there. Can you do it in your head? 12x. 36 moved there is what? Minus 36. So plus 12 is minus 24x. And then fortunately 36 and 36 are completely gone when I move it to the left. Which method you prefer to solve this? This is a quadratic equation. You can of course use ABC formula, but what is C in this problem? 0. But I told you that whenever C is 0, I don't recommend you to use ABC or PQ formula because factorization is the best and fastest way.
Just divide both sides by x.
No, I told you that before. Don't make the same mistake over and over again because when you divide by x, you implicitly assuming that x is not equal to 0 and you get one answer. There is 0 as an answer as well. Yes? So what you have to do, you have to factorize. Don't fall into the same trap more than once. If you remember, I talked about this naive way of dividing when I was teaching that case when C is 0. Okay, so the important thing is to what? To take an x out, and then you say x minus 24 is equal to 0. Which rule is suitable now? Do you remember the name? I have two numbers multiplied, and the answer is 0. And I saw some of you in the exam did it for 1 and 2. This is only a property of 0, the property of 0. If this number is 1, 2, or other numbers, I cannot continue the way that I want to do it. That is called what? The zero product, yes, rule. If the product of two numbers, this is one number, this is another number, the product is 0. This cannot happen unless at least one of them is 0. So this means that either x is 0 or this one is 0. But this one is 0 means x is what? 24. So when you divide, you do not see the 0 one. Yes? Okay, but this doesn't mean this is correct because this is a root equation. I have to put this back into this equation. So I would say x equals to 0. I want to check it. So I go to this original one. Instead of, so I would say left-hand side is equal to, instead of x here and x there, I put this number. So it becomes 0 plus 1 minus 6 the square root of 0 plus 1 plus 5. And then I simplify to see if it reaches to the right-hand side or not. So 0 plus 1 is of course 0. 1. 0 plus 1 is 1. Square root of 1 is 1. 1 times 6 is 6. I have a negative sign. And then I have plus 5. What the answer becomes? It is really 0. And it is equal to the right-hand side. So then I have to go back and say that yes, this is acceptable. I have to do the same thing for, so you see that if you do it in that way, Hasbullah, you will lose this 0, which is indeed the solution. For 24, I would write the left-hand side is equal to, what is the left side? 24, I replace every appearance of x with this number 24 plus 1 minus 6 square root of 24 plus 1 and then plus 5. Is that true or not? 24 plus 1 is 25 minus 24 plus 1, 25. Square root of 25 is 5. 5 times 6, 30 minus 30. And then plus 5. Is it acceptable? Yes, because that also becomes 0. That's the right-hand side. So I am lucky. Both of them are acceptable. So this equation has two roots. Okay. Yes?
Okay. The equation, first I put, so I tried to, only get minus 6 squared x plus 1. So I did, I took 5 away, x plus 1 away, and then I got the answer 36.
I can do that, but this should work. It is not wrong. I will do your to see where is your mistake, but be doing another way. Do you see any other options to do it? I want to use this as an excuse to remind you and teach you this. Do you remember the method of auxiliary variable I introduced? Do you think it's useful here? So let me solve the same problem in a different way so that use it as an excuse to review that. So the method of auxiliary variable, but now do you think what should I call the capital X here? So method 2, auxiliary variable, okay? So that is correct. If you like that method, that is correct. But I also to tell you what is the auxiliary way. Which one do you think is good to choose as my auxiliary variable here? Yes?
X plus 1.
No, if you choose x plus 1, it is not bad. It's not very bad, because if you say x is x plus 1, then equation becomes what? X minus 6 square root of x plus 5. It's not bad, because this is simpler than it looks like there. But I have a better option, yes?
Maybe x squared, because then I can remove the.
Yes. So this is the way that I prefer. So I would say let capital X be equal to square root of little x plus 1. Okay, this is the way that I introduce it. So let this one happen. But I told you that the method of auxiliary variable is successful if I can get rid of all the old variables in favor of the new variable. So if this is the case, then to the power of 2, x to the power of 2 is simply x plus 1. Yes or no? And I go back here, instead of x plus 1, what am I allowed to put? Capital X to power 2. And then I have minus 6 square root of x plus 1. But the square root of x plus 1 is called capital X, so it becomes minus 6x. And then I have a 5 at the end, and equals to 0. So you see, it is more efficient to do it in that way, because by introducing an auxiliary variable, I change this a little bit subtle equation into a very simple quadratic equation. Either you use ABC formula or PQ formula. So let me use ABC formula to solve it. So A is 1, B is minus 6, C is 5, D is B squared minus 4AC, which is this 1 to power 2, 36, 4 times this one times that one with a negative sign is 20, which is 16. And the answer x becomes what? Is minus b plus or minus the square root of capital D divided by 2a. So minus b becomes 6 plus or minus the square root of D is 4 divided by 2a is 2. So I have two answers for the capital X. The capital X is 6 plus 4, 10 divided by 2, 5. 6 minus 4, 2 divided by 2, 1. But be careful, these are capital X's. Okay? But I want to find the little x. So it is simple, because if capital X is this one, yes, so the answer, I raise it to power 2, it becomes 25. I move 1 to the other side, x becomes what? 24. But because I have already checked that this is not a false root up there, so I know that this is not a false root. But x equals to 1, it means the square root of x plus 1 is equal to 1. I raise it to power 2, x plus 1 becomes 1 to power 2 is 1, so x becomes 0. And because I have already checked this is the correct answer, this is also possible. So remember that the method of auxiliary variable is useful in any context that something is repeating itself in the equation. It doesn't matter if it's a quadratic equation, it doesn't matter if it is a root equation, fraction equation, or whatever. Okay, let me answer your problem. What was you were saying? Ismail, so you said, what did you do?
Yeah, so I put 5 on the other side, x on the other side, and 1 on the other side.
Okay, so let me just do that. So it means that you kept this minus 6 square root of x plus 1, and then 0 is already there, so 0. You moved x, 1, and 5 there, so it becomes minus x minus 1 minus 5, yes? So then it becomes minus 6 square root of x plus 1. Of course, this becomes minus x minus 6. Then what?
Yeah, and then I divided by minus 6.
Okay, if you divide by minus 6, this becomes what? Square root of x plus 1. if you divide by minus 6, this one becomes plus 1. But this one also should be divided. Did you do that? Okay, so it becomes x over 6. Yes? Okay, I don't like it because you are making trouble by making fractions, but it should work. It is not wrong. Let us see why it works. It doesn't work. You raise it to power 2. The left side becomes x plus 1, but the right side becomes the first one squared, 2 times the first one times the second one, and the second one squared. Did you write this or not? Okay, so you just wrote this one and that one? Yes? Okay, so I have to execute you. Because why you should fall into the same trap over and over again? Okay, this is not hard, by the way. So if you write this box plus something to power 2, you need to just know that, okay, this is not true. That's it. There is no way that I can teach you. You have to be aware of your mistakes. Any questions? Okay, so now let me try to write some equation here. Wait for you, okay? So one equation I want to write is not a hard one, but I want to see how many of you can manage to completely solve it. Because if you do this, it means that you really understood everything you need. Of course, there are some harder problems that we will involve, but that's a matter of practice. So this is the question. Square root of x plus 1 minus x is equal to minus 5. This is one equation. If you finish, don't stop and do this one as well. The problem is x plus 2 square root of 1 minus 3x equals to 3. Yes? I will wait for you. So I'm writing them here. So just do this one. After that one, do a little bit harder one, which I already wrote here. So what was that? X plus 2 square root of 1 minus 3x equals to 3. Let me write one more here. This is a little bit more interesting one. I have a square root, a big one, and then I have x minus the square root of x again. And then I have on the right side square root of x minus 1. I want to solve. It means that I want to find all possible x's that makes the left and right equal. Yes? Okay, this is good. I want to wait for you more. Okay, so tomorrow I will start with solving these 3 equations. So one more sessions we will work here. Thank you very much.